Hey everyone, today we'll be working with React Native and more specifically with the flat list, which is the virtualized list underneath. And I want to tell you or give you some hints about performance when you take a look and want to load a lot of items in your flat list. So if you are doing pagination, for example, infinite pagination, for example, you want to know about them because they really help you on improving the performance of your flat lists. So for example, the flat list is always already based on the virtualized list, which while you scroll removes some items from the top, or while you scroll backwards, then it removes some items from the bottom, even though you have more items available on the data prop. That will happen underneath, but you can tweak that behavior, and that's when you basically can tweak the performance of your flat list, because sometimes your items are not easy items, so you need to do some computations to create them from the data that you receive, or you need to speed up the loading time, for example. So all of that you need to know so that you can improve the performance of your lists and have a really smooth, provide a really smooth experience to the user. So the first one I want to show you is the OnEndReach threshold, and we can say like 0.5, and then the OnEndReached will be a function which we'll call console log OnEndReached, and pretty much that's it. So when the OnEndReached threshold gets hit, or we reach that one, the OnEndReached will be called. So if I go there inside, you will see that this one prop is how far from the end in units of visible length of the list. So the units of visible length of the list is basically, for example, for our list is the whole, so our list is this one, right? So it's the whole screen pretty much. And the bottom, so how far from the end of the bottom edge of the list must be from the end of the content to trigger the OnEndReached callback. So if you have a 0.5, will trigger OnEndReach when the end of the content is within half the visible length of the list. And this one is pretty much like, you can imagine that when you have the list, the flat list uses the virtualized list, and that virtualized list basically removes items as they get out of the view, basically. But the thing is that you can imagine here that we loaded several items and they are there, they are in the end. So when you are 0.5 in terms of the view, the visible length, so 0.5 will be half of this one, right? When we have these items, only this amount of them below these, right? And we, if we scroll more, we reach basically the end of the items loaded so far, then that one will be triggered. So yeah, that's it. So the OnEndReached, if I'm here, then I will start to scroll, and then when half of them are waiting here to be shown, when half of the visible length is there, then they more or less at the middle of the screen, pretty much, they are triggering the OnEndReached. So for example, if I now put it at 1, they will call you much sooner, right? Because yes, it's already called. So because, yeah, you have these one amount of items below this stuff. So like I need to scroll one full view, and then when I scroll one full view at that, when the last item is at one full view from the scrolling position that we are, then that gets triggered so that we can load. And so if you increase that number, pretty much you are saying like, okay, and it will be smoother, right, if you increase the number, because you have still a lot of items to scroll below this point. So one full view, for example, in the case of 1, and so you have a lot of them still to scroll, so you can keep scrolling while you do the connection to the backend and get more items. If you decrease that number, you have a less buffer basically. So you need to take that in consideration and play with it, taking in consideration also the complexity of the item that you are loading first of all, then the complexity of the design that you are loading on your screen, and yeah, then you can tweak that one. So pretty much this one is a really nice one, for example, when you are doing pagination and an infinite pagination, because you keep scrolling and you keep calling for the next page when the OnEndReach is called. Then the other one I wanted to show you is the window size. And the window size, I can say, for example, 10. And this one, it's a really nice one. So basically it's the maximum number of items rendered outside of the visible area in units of visible lengths again. So if your list fills the screen, then window size 21, the default, will render the visible screen area plus up to 10 screens above and 10 below the viewport. So yeah, 21 is a lot pretty much. So you can, depending on your use case, also decrease this number, right? Because as you can see, 21 will be one full view plus 10 above. So pretty much you can think about it like, in this case, one full view plus 10 below, 10 on the top. So it's a lot of items, right? If your API returns 50 pages of 50 items, then all of them will get loaded, right? And when you scroll, of course, it will be really smooth, but you have a lot of stuff to render in the screen at the same time. So if your items, these ones here, are complex, then if you load a lot of images, you need to do a lot of calculations, for example, to present your information or something like that, then that gets a little bit complicated. And so you have a lot of stuff loaded at the same time, and the performance starts to decrease, right? So when you feel that you have pretty much these one is when you start to see that the performance is getting worse performance, then you need to tweak this stuff, because if you have less items to load, then it will load faster while you scroll and all of that. So that's it pretty much on the window size. And the other one I would like also to is the initial number to render. So this initial number to render can be, for example, 5. And I wanted to tell you, basically, when you start to render, these ones, the first 5, would be the initial numbers to render. So, for example, if I scroll down, these 5 in the beginning will never go out of the view. So they will never be removed from the list. So pretty much if you scroll really fast to the bottom and load 10 pages, for example, and then you scroll fast to the top, you will see that the first 5 will still be there. So they didn't get removed. So for example, you could say, okay, my first items on the list are the really important ones. So I want to render, for example, in this case would be 10 or something like that. So you can say that. You can also say that, okay, I'm loading an infinite list, so I don't care. I want to have items here. When I keep scrolling, they will appear as blank, right? And then they get loaded more and more while I do the pagination. And when I get back to the top, I want also to see the same behavior. So they will not be there. So in theory, you can put these ones as 0, but I would advise one thing in here. So if you put these at 0, you can do it, but there's one thing to do. If the items in your list are not always the same size, and they are computed dynamically in a way, this one is nice to have at least like 1 or 3 or whatever you want, because otherwise you will get flakiness on the list. I don't know why, but that's pretty much, I think it's because of the height. So if you don't have the same height on all of them, and pretty much because of the calculations that they need to do probably, at least I got that from the apps I developed. So and I needed to keep at least 3, for example, and then they are always on the top. So basically they can calculate easily against that first tree. They can calculate all the others. If you don't have basically an anchor for them to do the calculations on these items, then you will see some jumps on the list. At least I got that. So I needed to put 3 here, for example, or 5, depending on the use case you have, of course. But that simplifies these kind of lists where the items are not the same height. If they are the same height, I think you don't need to care about this. And in theory, you could say 0 because I load my items and I don't need to have some of them always there. In the beginning. So for example here on the WindowSize I kept it 10, but you can of course do 5, and again it's 1 viewport and then 4 to the top, 4 to the bottom, right? So in that case you decrease a lot the number of items rendered as in one go. And of course this doesn't just to recap, this doesn't mean that your backend needs to return these specific number of items. So the data here can have, for example, 100 characters, but the list itself will only render in terms of component in the tree. It will only render these 4 to the top, 4 to the bottom, and 1 viewport, plus 1 viewport, the one you are seeing. So it's not dependent on the number of characters and vice versa. So this is only the ones that, because basically when you are scrolling, you are rendering more items, and you are also removing some other items from the top which are not visible anymore. So pretty much you don't need them, and that way you keep memory low, less animations to do at once if you are doing animations on the elements of the or of the list, for example. So all of that simplifies and gets smoother. And of course, these numbers again are really dependent on the use case, but they are pretty cool and also really useful when you are doing performance improvements. And pretty much you need to do performance improvements, I think, when you start to see that the performance is getting worse. But of course you can always think about that, especially if your application will hit the stores. Another one I want to show you is the max to render per batch. So this one basically, for example, let's say 5. Every time the FlatList wants to render more items in your FlatList while you scroll up or down, it will take this number and will load that number per batch. So every time it wants to load more, it will use this one. So you can also tweak this one, like 5, 10, whatever. You need to tweak it according to your use case again, as I mentioned before. But this one also allows you to tweak a little bit how fast that happens. And of course, if you increase this, you will load more items. But again, it will also take more time, right? So it's also a balance here, as on the other props. Cool. So now you know a couple of props that you can tweak in your FlatLists, and according to your use cases, you can tweak them so that you can improve the performance. You can do infinite scrolling up and down. You can improve the loading times, and you can improve the experience to the user and how smooth loadings happen in your FlatLists while they scroll up or scroll down, and how does the item appear on the FlatList. That depends on how much data is loaded, and pretty much that's it. So I hope you can improve your app, so go ahead and start to tweak them in your FlatLists. If this video helped you in some way, please consider subscribing so that you get notified about new content that I post, and also because it helps grow the channel. Feel free to share your questions and thoughts in the comments down below. Till next time, keep in the loop.